Hey guys, this is Carl, and we're just going to touch base just real quick about just kind of a simple linear regression. What we have here is a sample from statistics students. We got students 1 through 10, and their aptitude test and their final grade. Now what this data is that for these 10 students entering a statistics course, they took an aptitude test prior to make sure that they could at least be ready for the course going in. And so these are the scores from those tests. See, in this setting, in this scenario, what have you, they'd have to score at least a 70, kind of an unprepared test, almost like an entrance exam in that sense. And so here are the aptitude tests, and these are the actual final grades of the statistics course. And so what we're going to look at with the regression is to see whether or not there is a relationship between the aptitude test and the final grade or outcome. So we've got your independent variable and your dependent variable. What does that mean? Is final grade, the outcome of final grade, dependent on the aptitude? So that's what we're really getting at here with the aptitude, with the simple linear regression. So in that sense, what we're going to get started with it. So we'll go under stat, just to give you a sense, and then we're going to go to regression right here. Simple linear regression. And what we're going to do is essentially our x will be variable 2. This will be our independent. And our dependent is the final grade, variable 3. What we're going to do is just we're going to basically graph this and put it in the system. And you can see we already have, it's really, with StatCrunch, does a lot of the work for you in that sense. Where now you just have to work with interpretation. So, just real quick, so we got all this information to have. Sample size 10, the variable 1, variable 2. This is actually the linear regression equation. 557.68 plus 0.33. So that is our actual equation. So what does the r squared mean? Just to give you a sense. This is the coefficient of determination. So what this means, 0.53, just to give you a sense when you want to interpret data in this sense in a regression, that 53% of the variation in statistics based off of this is contingent on this. So that kind of gives you a sense that this is a good fit, that final grade is contingent on the aptitude test, at least from this student sample. And so just to give you a sense of what that looks like graphically, see, StatCrunch could show you this graphically in this next tab, the fitted line. And it will show you the equation right here when you click on it. Function clicked, y equals 57.68 plus 0.33. So what this means now is, and what's the point of this? Well, what this means can tell you is that if you are, based on this model, when to figure out what would be the estimated score of somebody if their aptitude test was a certain grade. And that's really what this is all about. It's about prediction. What's a good predictor? So for like a 95-ish, what would that be? It kind of correlates to getting almost 90 with a certain degree of confidence, 95% confidence, in fact. So this really kind of a general principle with simple linear regressions. And we just hope this helps, and just let us know if you have any questions along the way. All right, thanks so much. Bye.